What's up, guys? Welcome back to the KULLYCO YouTube channel, where we do all things fabrication, engineering, and design. Today, I'm going to show you step by step the exact process that I use when TIG welding thin wall titanium exhaust tubing. We're going to dive into welding equipment, machine settings, gas pressures, material prep, and actual techniques when TIG welding the tubing. On the table here, we have a really wild system. This is an exhaust I just built for my new custom bike project, the KC1200. In terms of exhaust building, this is getting pretty wild. This is all 1mm 039 CP1 titanium. As you can see, it's a V-twin system with a step header into an X collector with a fun screen system in the back. Very inspired by MotoGP. I'd like to show you guys this system up close to just give you a visual of what we're going to be learning about today. Let's get rolling. We're gonna start with welding equipment. As far as the welder, I'm using a Miller Dynasty 210. I use a Victor dual regulator. The left side is the CFH through the torch, and the right side is the CFH for back purge. As far as torch equipment, I'll be using a number 16 gas lens with a 16th inch 2% serrated tungsten sharpened to a point. For back purge, I'll be using these aluminum inserts. One of them will be the feed for the argon into the part, and the other will cap off the part, but just allow enough to bleed through. If you're unfamiliar with back purge, you'll learn more about it later in the video. Before we get too far here, I want to talk about the different ways that you can actually weld this titanium tubing. First off, you can weld it with or without filler rod. I would say 90% of the time I use filler. Most of the products I build are for the motorsports world, where the exhaust temps are high and the material's being tested, so I like that added level of strength and insurance. Now, you can also not use filler rod, which is called Autogenius welding, and that's simply where you're just fusing the material together at the seam without using filler. So, this entire system, I used filler on all seams. I wanted that buildup, that insurance, like I said. This part was Autogenius welded. The welds are really flat and smooth, and they don't really have a crown like the filler. As you guys progress with your welding, I'm gonna urge you to use filler all the time. However, when you just start out, Autogenius welding is certainly simpler, where you only have to manage the torch. I'm gonna show you a close-up view between the two different welding types. The two look very similar, but you'll see on the left, the seams with the filler have a little more crown. Not much. And then the Autogenius welded part is a little bit flatter. Lastly, something I wanted to mention, you can use trailing shields. This is basically a component you can add to the torch with another feed line to increase the shielding and the gas flow around your weld seam. Honestly, I never really use these. I'm sure I'll have guys give me pushback on this, but I find that when it's attached to the torch, it's kind of cantankerous, and they sort of work, but not really great. So honestly, everything you see on the table here, including this exhaust system, was welded with this cup, this tungsten, and this torch assembly. But I wanted to mention it. For you beginners and intermediate welders, this is not something you should be concerned about. Let's just talk a little bit about titanium in general. Why use titanium, and what purpose does it serve, and what's important when we're welding it? So first off, titanium is a non-ferrous metal. It does not rust, it does not corrode. Very widely used in aerospace and motorsports. So titanium is very strong and it's very light. So the same part out of titanium versus a steel alloy is generally about 50% lighter and about 50% stronger under certain loads. But also it's more heat reflectant than steel alloys, which is important for exhaust. The more heat reflective the alloy is, the higher temps it'll keep inside the exhaust system, which is smaller exhaust particles, which is faster moving exhaust. It's important that it's really light, it's strong, it's non-corrosive, and it's a good heat reflectant material. When welding this material, there's some things that I want you to think about. Titanium is brittle. It's not as forgiving as steel alloys. So when welding it, you have to be precise. Yes, you need a good weld, but most importantly, you need to make sure your gas coverage is phenomenal. As you'll see, most of these seams are like a warm gold, almost white color, and that's really good. That's what you're going for with titanium. Now you'll see some blues and some purples here and there in the seam, and that's okay where the coverage wasn't perfect. But you're going for the white gold color everywhere. What you don't want is like a gray, crusty looking weld where the coverage was not there. That's where you're gonna get into sort of a contaminated, brittle area where it's susceptible to break. So to sum it up, when welding titanium, your coverage has to be amazing. Also, when we were looking at equipment, we were talking about back purge. So what back purge is you're actually gonna fill the inside of this part, fill the inside of this exhaust with argon, the welding gas, while you're welding the seams on the inside. What that's gonna do is shield that molten weld on the inside with gas to keep it clean and free of contaminants. Back purging is very important with titanium. You wanna make sure the bottom side and the top side of that weld seam when you're welding is totally covered with shielding gas. So just to sum it up, the most important part when welding titanium is your gas coverage. All right, so enough with all this jargon. You guys ready to weld? Me too. We've got some test material in front of us here. We've got 2 straights and 7 seams. This is 1mm CP1 titanium, the exact material I made this exhaust system out of over here. We're gonna weld with filler and Autogenius, and I'm gonna show you all the settings and the gas pressures that I use for both. So first, welding with filler rod, machine settings. Of course, you're gonna wanna be on DC. We're gonna go to probably 35 amps. P-flow 1.2. I keep it here for basically everything. That's for post flow. We're gonna run 12 seconds. That's the flow of argon after you lift the pedal to shield that molten weld from contamination. For gas pressure, we're gonna run 30 CFH through that number 16 nozzle. For back purge, since it's just a small test part, we'll probably run about 3 CFH. Right now, we're just kind of prepping a few things here. I like to acetone all of the seams. I should be wearing gloves. You guys wear gloves. Next, for you guys who are unfamiliar with the back purge, you'll be able to see that here and kind of what that looks like. I'm just using the tin foil to seal the gas off. The feed in one end, and then the cap in the other end. But it's not fully capped. The back purge needs to be able to bleed through ever so slightly. You don't want it sealed off in there. Otherwise, the gas will try and push back at your weld and it'll blow it back out. Since coverage is very important with titanium, like we talked about, you have to be specific about how you're welding it. When you go to do a rip and you lift on the pedal, that post flow of 12 seconds that we set it at has to cool that weld all the way down and keep it clean and free of contaminants. It's sealed off, it stays white and gold and it doesn't turn gray. When welding titanium, this is kind of the downfall, is you can only do short rips. So all of these seams that you saw in this system, they were 12-ish dips every start and stop. 1, 2, 3, 4, 5, 6, 7, 8, 12, and then lift the pedal and let that post flow go to work to cool and seal that weld off and make sure that it doesn't get any contaminants in it. And then reposition. Go to strike that arc, get the puddle size that you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Lift on the pedal and then we're gonna let that post flow do its thing. Cool that weld down, seal it off, keep it clean, and then we'll reposition and we'll do 12 more. It's gonna take you a while to weld the titanium. That is the one downfall, because you can only do short runs and then you're waiting on 12 seconds of post flow and then 12 more dips. You're gonna go through a lot of gas, so just prepare yourself for that. You could do long runs and not keep the weld gold and silver. You could get it purple and gray and all these things, but I don't recommend it. I've never had an exhaust system fail, knock on wood, and I've always done it this way. Like, basically, if there's color in the weld, I'm not happy. I want it that color. Also, the nature of the welding with titanium is different than steel alloys or aluminum as well. I think it's because of the melting temperature. I don't know for sure. I think the titanium has a higher melting temperature. Titanium is sticky. Like steel alloys, you can kind of be TIG welding, you can sort of slide the rod in from the front. You know, you can be a little bit more casual in terms of your dipping protocol. But with titanium, you have to be very precise. Otherwise, it'll kind of stick to the material and you'll go to kind of try and rip it off and it'll mess your whole program up. So you want to try and dip right into that pool. All right, let's do a couple rips here. See how I let that post flow do its thing? We keep welding here. I'm gonna let you guys in on a very, very important principle to me in terms of TIG welding, just in general. When I'm TIG welding, it doesn't matter if it's 1mm titanium, 18 gauge stainless steel exhaust, chromoly frame building, aluminum, anything. I am looking for the perfect desired amp for that weld, for that material, and for that thickness. I want to be able to slam the foot pedal all the way and have that heat, have that puddle size optimal to where I can just rip, okay? Where I can focus on the hand movements, the weld, the rotation of the torch. What I'm trying to do is eliminate the variable of the foot pedal. Now, this doesn't always work absolutely perfect, but being really, really, really close on your amperage is going to make your life a lot easier. You want to eliminate that half throttle thermostat variable, okay? What a lot of guys will do is they'll kind of set their amperage in a range and they'll run that pedal kind of halfways, and you can totally do that. I used to do it all the time. But what can happen is when you're trying to run that foot pedal in a half range like a throttle, you're susceptible to that amperage surging. For me, I want to eliminate as much variable as possible. So I want to try and hit a perfect amp, and in this case I have it at 35. So when I'm welding this, I have the foot pedal slammed all the way down. So that eliminates one variable. Now I can just rip. You know, now as the material heats up, you know, you might have to run it up a little bit, but not near as much as like half throttle. You know, if you're welding 1mm titanium, you're not trying to have your machine set at 60 amps and then run half throttle at 30 amps, or what the material actually wants. And for you beginners, don't think too hard. You're in control of this machine. You're in control of that pedal. Don't overthink this. Don't think too hard about your torch height. You know, keep it an 1/8 inch off. Just relax. Just do your thing. You know, try and rotate the cup a little bit with the material, but all this stuff will come to you with the more practice that you put in. the seams that I just did up close. You can see there's a little bit of a crown there from filler, but it still lays pretty darn flat. Next, I'll show you some Autogenius welding without filler. So a couple settings are gonna change for the Autogenius welding without filler. So I'm gonna use pulse, and I'm gonna go 1.2 pulses per second. That's a good range for me. And as far as amperage, I'm gonna go up a little bit in peak, probably 40, maybe 45 tops. We'll start there and see where we're at. When you're using pulse, the peak has to be a little higher to get the same width of weld that you're looking for. So our approach is going to be very similar with Autogenius. We're looking for a peak amperage where you can just slam the pedal and you don't have to run it, you know, to get the right weld that you're looking for. And we're probably going to go 12 pulses per start and stop, just like 12 dips. Make sure that we have optimal coverage. The reason that I use pulse is I like that psst, 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 when I'm not using filler to put that pattern in the seam. .45 peak was decent. Could maybe go up just a little bit on the peak, maybe to like 46 or 47. So when you're doing this, you're gonna slam the foot pedal and you're gonna pulse in one spot until that puddle is the width that you're looking for. It's up to temperature, and then you're gonna start moving the torch with every pulse. So we're gonna start. We're gonna wait for it to get to size. Okay, then start moving. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, so let's check this out. First up, we'll look at the Autogenius welding here with no filler. That's the first 3 seams. You can see that it's very flat. There's no crown. You're just fusing the material together. And then over here is the first 3 seams that we did with filler. You can see that there's a little crown there. It's not quite as flat, but I don't use a lot of filler when I am filling, just small dabs. But there's the difference between the two. It's hard to tell, but if you're a welder, you can tell when something is fused or when you use filler. Doing these short runs is not fun. I'm in a full understanding of that. In a perfect world, you'd have a dialed in trailing lens like I showed you earlier in this video, where it's following you and you can do long rips, you know, at 30 or 40 dips like I do on stainless steel, and it would cover the weld and keep it all white and gold like this. But for this small tubing, finding a trailing shield that's tight enough to the material to where you can rip it like that and it to cover it properly is very tricky. Red one I showed you earlier is close, but it kind of works, it kind of doesn't work. It doesn't cover it optimally all the time, and I've just found that it becomes more of a pain to run a trailing shield with the extra hose and the heavier feel, and then the coverage isn't quite as good, that I was just like, you know what? Like that, it's a problem. It's a pain in the butt. So I just end up doing these short runs where I know the coverage will be ideal and I don't have to worry about it. So if there's any world-class welders watching this video, and you have an ideal trailing shield for small OD tubing like this that would sit real tight to the material, let me know. I would give it a shot. All right, guys, that's going to conclude today's video. Don't be afraid of welding titanium exhaust. It's a lot of fun. Just remember, with titanium, it's all about the coverage. Appreciate you watching today. I hope you were able to get value out of this video and learn something. If you're new to welding or fabrication, do not give up. Keep going. Small, seemingly insignificant steps, putting in the reps every day, will yield favorable results over time, just like anything else. So as always, I'm rooting for you on your fabrication journey, and we'll see you next time on the KULLYCO YouTube channel. See you later.